Let's take a look at a couple of the important concepts that go into object-oriented programming. When we talk about OOP, we sometimes say that there are four pillars of object-oriented programming, four concepts that are really important and that really make up the foundation of this way of programming. In this video, we're going to take a look at abstraction and encapsulation. The other two are inheritance and polymorphism, and those are a topic for a different time. As before, these concepts really apply to object-oriented programming in general, regardless of the programming language that you are working in. So in this video, we're going to talk about understanding these concepts and understanding how they apply to our code. We're not going to get into the nuts and bolts yet of how to actually write this code in our programs. We'll start with abstraction. Abstraction is when we take something that is potentially complex or complicated and we reduce it down to something simpler so that we can work with it and talk about it. Put another way, it's this idea of hiding details and hiding complexity inside something that's packaged up in a simpler way. We do this all the time in our lives. If you ask me what I did this morning, I might answer, oh, I drove to campus, right? Actually, it looks like maybe I rode to campus in a police car based on that image, but whether I got there in a police car or my own personal vehicle, the idea is that it sounds really simple. I do it every day, but in actuality, there's a lot more to it. This morning, first I opened my car door and I sat down, then I started my car. I backed out and I turned west, then I drove down the street, and when I got there, I turned left at that stop sign, and so on and so forth. You get the idea. All of those things had to happen, but when you ask me what I did this morning, it would be crazy if I just started listing all those things. Instead, I give you an abstraction of what I did. I said, I drove to campus. I drove to work. The details in this case don't matter. In terms of our conversation, if you're saying hi to me in the hall, it doesn't matter what the details are. You just want the general idea. That's abstraction. In object-oriented programming, if we want to work with something complex, like, for example, cars in a racing game, we can use classes and objects to represent those complicated objects, those complicated things. And it doesn't save us from doing the work. We still have to create those classes. We still have to write the code that makes all of this functional. But once we've done that one time, now we have this nice abstract idea of cars in our game that we can just work with by themselves. And we don't have to get into the details of how they work anymore. And in fact, if I'm working on a programming team, maybe I don't have to have anything to do with how the car works. There might be a group of programmers writing that completely separate from me, and then they're going to give me the completed car class. Or maybe I've already written the car class for a previous project, and I'm just going to reuse it. Those are both advantages to object-oriented programming. But the point is, I don't have to mess with the details now. I've got a car class. I know what its attributes and its behaviors are in the forms of variables and methods, and now I can use those to make objects and manipulate those in my game. Hopefully it's kind of obvious that methods are a big part of this abstraction. You can imagine kind of a drive to work method if there were a Professor Tim class, right? I abstracted all those details, all the step-by-step stuff, and I could just put them into a function or a method called drive to campus, and that's a big part of our abstraction. You've actually been benefiting from the idea of abstraction probably since the very first time you ever wrote any kind of code. For most people, the first thing you ever do when you're learning to program is you just make it output something simple onto the screen. And when you did that, you didn't have to worry about all the endlessly complicated things that had to happen in order to make the correct pixels on your monitor light up to form those words and that message. No, you just probably called the print method or the print function or the write method or write line or something like that. You used an abstracted method to take care of all of those details so that you could just focus on the big picture idea of, hey, I want to make it say hello world on my monitor. In fact, I would go so far as to say that if you have any programming experience at all, you've probably kind of internalized this idea of abstraction and you just do it naturally. We don't really even have to think about it. It's a big reason why we want programmers to write functions and methods right away when they're first learning to program, so that they can learn to bundle up this kind of related set of steps into one abstracted idea. Very closely related to the idea of abstraction is encapsulation. Encapsulation is about taking all of those ugly details, those really complicated things that we abstracted away into a general idea. And we're going to put those all in a safe spot where nobody can come along and mess with them. Nobody can inadvertently break our code. Let's get back to the idea of this car. I drove my car into work. I drive in pretty much every day. I drive my car on weekends to go to the store and get my girls to the places that they need to go. And maybe because I'm old and I've just been doing it a long time, it starts to feel really simple. Okay? And in fact, it's simple enough that if I were to find your keys and go out to the parking lot and jump in your car, I'm pretty sure I'd be able to figure it out and drive away without too much trouble. But a car is actually really, really complicated. There's all kinds of stuff going on in there. If I pop the hood and take a look at what's just in the engine compartment, I'm probably going to be fine. I can look around and see kind of what's going on, but I don't understand any of it. And if I start poking around and touching things, it's really only a matter of time before my car is going to stop working. Hyundai was smart enough, in my case, to encapsulate all of the complexity and all the detail that's involved in the operation of a car. And they've given me access to just the things that I need to have in order to operate it. So I've got a steering wheel, I've got some pedals, I've got a gear selector and things like that. The rest of the car is all encapsulated so that I don't mess with it. Let's apply this idea of encapsulation to a programming scenario. We'll stick with this car that we've been talking about, but now we'll imagine that we're working on maybe a self-driving car project, autonomous vehicles, and we're going to be writing the code that does the driving, right? That controls the car. So we have our car class, and in particular, I'm interested in those two attributes, which are very closely related to safety, right? The speed that a car is going and the direction it's traveling in are both concerning if they aren't managed appropriately. And this is potentially a big project. It's hard for one person to write an autonomous car program, right? So we probably have a lot of people working on this project. What happens if somebody on another part of the code comes along and they're manipulating our object and they set the speed of the vehicle to 200 miles an hour in the middle of a downtown busy street? Or maybe they just set it to some invalid value, like they accidentally flip it from 40 miles an hour to negative 40 miles an hour, or they turn the car into a direction that's not safe. These are all problems, and these are all things that we can't really control as long as people have direct access to those attributes. I mean, we have to just rely on those people to be careful. Or more importantly, to not make mistakes, right? I doubt they're going to do those things on purpose, but they might have a bug in their code that puts the car into an unsafe situation. So encapsulation can help us address this issue, because in encapsulation, the idea is that we're not going to give our other programmers, or us in another context, we're not going to give access to those variables directly. If someone or something needs to adjust the speed of the car, we have perfectly good methods for that, right? We have an accelerate method, we have a brake method. And in those methods, whoever's implementing the car class can write code that ensures it behaves in a safe manner. It can make sure that it doesn't accelerate too fast in an area where there's a lot of traffic around. It can make sure it doesn't turn left if there is an obstacle over to the left. And so the idea of encapsulation is that we're going to kind of protect those variables and give access just to the methods that are used to manipulate them. And that's a really big part of what we do with our functions or our methods, incidentally. Even if you've done some object-oriented programming in the past, you may have just made these sort of generic kind of set variables that really just still set the variable to whatever value is passed in. But what's important is that we can write code to make sure that code is valid and appropriate before we make any changes to our data. Now, the support for all object-oriented programming is different across different programming languages. Some languages have really strong object-oriented programming support and some not as strong, especially with encapsulation. So if I'm working in what I would consider a strong OOP language like Java or C#, those languages provide a keyword called private that allows me to set up encapsulation very easily. I can say that the speed variable is private. I can say that the direction variable is private, and the runtime environment will not allow outside access to those. And when I'm teaching in languages like that have this private keyword, what I tell my students is that we always mark our variables private, and we never let anyone touch our privates, right? We never let anybody have access to our privates. If somebody wants access to our privates, then they can get that access through the methods that we've created to control how that access happens, right? So I guess this is probably a lesson for life beyond just programming, but mostly, obviously, it's meant as a tongue-in-cheek way to help you remember this. But in object-oriented programming, our default should be to make all of our variables private when we're designing our classes, and then we make public methods that give access to those pieces of data, and only as much access as they need. If they don't need, going back to our real life example, Tim doesn't need access to all the parts of an engine, so Tim probably shouldn't have that access. You're just asking for trouble if you give me a wrench and open up the hood. Compare that to a language like Python. Python doesn't have what I consider super strong object-oriented programming support. There's really not a private keyword in the same way. When you set up variables in your Python classes, they are exposed kind of automatically. So anybody can come along and they can change the speed variable. And the truth is actually that even in Java or C#, I could just not use those private keywords. I could leave those public, and I have the same problem. And often that seems like it's a much easier solution, right? Then I don't have to go to the trouble of creating those methods, and I don't have to go to the trouble of using them when I just want to change the speed. I know I'm not going to make a mistake, right? But if you're going to work in an object-oriented programming environment, then it's your responsibility to handle that the appropriate way, and essentially to play by the rules, right? That even if the language allows you to access things you're not supposed to have access to, then you have to leave them alone. You have to go through those methods. The idea is those rules seem like an inconvenience, but they are there for a reason. And if you don't like them, then I guess object-oriented programming is not for you, right? There's no use kind of doing this if you're not going to do it right. Okay, so that's really it for this overview, and now you can kind of move on to look at the details of how these things are implemented in whatever programming language you're using. So with that, I'll say good luck with your programming, and I will remind you never to let anyone touch your privates.